In this section, we are focusing on continuity and one-sided limits here at gotomath.com. And we're looking at this particular one-sided limit, but we're also going to talk about continuity. And I promise it's not that difficult. So let's go over to the whiteboard here. Alright, let's write down this limit. We had the limit as x approaches 8 from the right hand side, that's what this little plus sign means, of x squared minus 64 over x minus 8. Now I'm going to consider, we'll just give this, we're going to give this guy a name here. We're going to call it g of x. And the reason for this is because we're going to be looking at a theorem here in just a minute. And if we were to actually evaluate this limit, what we'd want to do is just evaluate it like we did in the previous sections, where we're trying to find the limit as x approaches 8. Now this means we're coming in from both sides. And so what I'm going to need to do is factor the numerator and cancel like terms. If you take 8 and you plug it in, we get 0 over 0. So that means we need to try to factor and cancel like terms. So let's just do that. Over x minus 8, and the limit as x approaches 8. So we can cancel those guys out, and so we have the limit as x approaches 8 of x plus 8. And as you can see, we do the direct substitution, we get 16. 8 plus 8 is 16. So this is equal to 16. Now, I'm going to actually draw a picture here, so maybe you can get a better understanding of what's going on. And we'll make the graph so crosses at 8, slope of 1. I don't know, we'll say this is it right here. And of course we're looking at 8. So we're just going to say, actually, we'll put 8 right here. Try to do something to scale here. And this right here is actually this undefined point, this missing point on the graph. And when we plug 8 in, we get 0 over 0. Okay? Now, I'm going to say a few things. This graph is not continuous at x equals 8. And the reason for that is because there's a hole in the graph. So think of it this way. A graph being continuous, or a function being continuous, let's say on a closed interval, and in this particular case, we'll just say on the real number line. But if you put your pencil down on this line and you have to lift it up to get to the other side, that means that the graph is not continuous. And as you can see right here, there is a hole. We'd have to stop and then here. Now let's talk about this, plus the plus side. This means that we're coming in from this direction. We're trying to find the limit as x approaches 8 of this line right here, coming in from the right hand side. So we're coming in from the right hand side, and we're saying as we get closer and closer to 8, what is our y value approaching? Well, it's approaching this missing point, which happens to be here at 16, which happens to be at 16 here. And so if we come in from the left hand side, right, what's our y value approaching? It's also approaching 16. So coming in from the left hand side, it's equal to some L, which is 16, and coming in from the right hand side, it's also equal to some L, and we'll call that L 16. Well, if both those L's are equal, then that means then that the limit exists, and so that's the reason that we can actually see it this way right here. Okay, so if we just evaluate the limit like we normally have, and we get some number, right, then that means that this right-handed side limit is also going to be equal to that number. So I hope that makes sense. Now just check out some of the other problems, and eventually I guess you'll get it. All right.